In our previous video, we looked at data visualizations for parts of a whole when you're looking at one particular question or field. We created a donut chart, a pie chart, and a tree map. Well, what if you have two variables? If you have two variables and they are both nominal, you can create what is called a sunburst. If you have two variables and one is nominal and one is ordinal, you can create a stacked bar plot. So let's look at how to create these in Python. All right, so just a reminder, we are using the workbook from drstephpowers.github.io/BIA, and we're doing the data visualization workbook. You will need the Excel files that you'll find when you click on this as well. So load those up into your Google Drive, of course, link to your Google account and import them in. So again, log in, save a copy, mount your Google Drive, import your data from where it's located in your Google Drive. And then we are looking at, we did donuts and pie charts. Now we are looking at, we did tree maps. Now we are looking at that. All right. Now we're looking at sunbursts. So a sunburst, as we said, is used when you have two variables that are both nominal. So to do a sunburst, you're going to import plotly.express, and we're going to call it px for short. In this particular scenario, we're going to look at question 23 and question 1. So question 23 in our survey asks about what campus they were associated with for bargaining. So they were at the north, south, or east location. And so in our visualization, what we want to see is if there's different priorities by the different locations. So what should be the top priority for the next round of bargaining for the different groups? So we want to take their locations, and then we want to look at the priorities within those locations. So when you create a sunburst, I'll just show you what a sunburst looks like. This sunburst here has the north, south, east locations, and then it has their priorities. So we can see that increasing pay is the biggest priority for east, and working conditions looks like it's slightly bigger than increasing pay for the south. And then for the north, we can see that much more equally distributed among them. You can, with this, zoom in and look at, so these are interactive. And so we can then zoom in and look at what's happening in the north. And then you can zoom back out by clicking again in the center, and now we can focus, say, on the south. So these particular types of data visualizations here are interactive. And this comes from plotly.express. We're going to call it as px. So we're going to import that package. What we're going to need is to create a table. And this table is going to need to consist of question 23, question 1, and then we need to know the number of individuals that are going to take up each of those combinations. So question 23 east and question 1 benefits, how many people prioritized improved benefits and were from the east. So it helps if we go back and look at the original table. So let's go to DF head. Okay. So what we're going to do is we're going to take question 23, we're going to take question 1, and notice we're using DF. So we are using the non-coded, so the sunburst here allows us to use the non-coded data set where it can clearly see that question 23 is nominal, it's categories, and question 1 is categories as well. And then we're going to use the column called respondent. And that's because it is unique to each. And so then what we can do is we can say, okay, well, let's find how many respondents we have for these combinations. So let's go here. So we're going to take DF and we're going to group by is our command here. Okay, so group by, as we can see, involves some combination of splitting the object and applying the function. And so what we're going to do is we're going to split the respondents by question 23 and question 1, and then we're going to count how many there are. So how many respondents? So that's what this is saying. We're taking question 23 and question 1, and we are going to split them based on the respondent category. So we just need something that is kind of unique. So you might have an index or a person number, ID number, and then we're going to count them. So what it's going to do is we're going to create then this table, and we're also here, we have it as reset index. And that way it's not simply in terms of which group had the highest number. We want it to be ordered so that here we can see here is all east, here is all north, here is all south. So we'll run this and create this table. And so your sunburst is going to use this table. It's using the combinations of question 23 and question 1, and then the counts for how many people fall into those categories. So then when you create your sunburst, we're going to call it figure so that we can tell it to show the figure. We're going to use the PX. Okay, that was our Plotly Express, and the command is sunburst. And it is going to use our count sum table. So make sure you've created that count sum table. And the path. The path is important. Question 23, that was the north, south, east. That's whatever's in the center of your sunburst. And so that's going to go first. And then question 1, that's going to be this outer piece here. And then we have values equal respondent. That's going to be these counts that we've created here. And the height, you can specify how big your sunburst is. And the last thing we want to do is show the figure. So we'll click this here, and we get this interactive chart as we just saw, where we can click east and show the details of east. And then you can click south and show the details of south. The order of your path is very important. We need the one that has the bigger categories needs to be the one first, and then you're diving into the details. So we look at the south location, we figure out what their priorities are, and so we need to list it in that order for it to be properly formatted. So we use the sunburst when we have two variables here, question 1 and question 23. They were both nominal, and we want to see the breakdown in terms of parts of a whole. The other graph we can look at here is if we have a combination of one nominal question and one ordinal question, and then we use what is called a stacked bar plot. I use a lot of stacked bar plots when I do surveys that have Likert scale opinions, where you strongly agree to strongly disagree, because what you want to show is you want to show how one group compares to the other in terms of their opinions. So to do this, we are going to use a crosstab. So we're going to create that pivot table or crosstab that's going to look at how many people fall into that combination of the nominal and then where on the Likert scale. We're going to import numpy as np so we can manipulate things, and then we're graphing with matplotlib.pyplot as plt. So let's import our packages. Then we're going to create a crosstab, and here the index, remember that's whatever is going to be your rows. Here we're going to do question 2. So if we go back to our survey, question 2 was what type of contract do you have? Okay. And then we have question 13, which is going to be one of our Likert scale questions. And that particular one is, how satisfied are you with the amount of hours worked per week? Okay, we could do this with any of these other scale questions here. In this particular case, we're using the coded data. Okay, so we're using df2. And because we don't really want the numbers, we want the percentages, we'll do normalize equals index. And that's because we want the total 100% to add up. When we add up the strongly disagree all the way to the strongly agree, for the part-time, we want that to add up to 100%. And for the full-time, we want their strongly disagree to strongly agree to add up to 100%. So we're normalizing over the index as opposed to normalizing over the columns. And we're ultimately creating this bar chart, so that's why we just called it bar and 1-3, because it's question 13, so we can keep track. And so we get this table here where you can see for the part-time, They're mostly congregating here 2, 3, so slightly on the negative side. If we go back to the question 13, how satisfied are you with the amount of hours worked? So our part-timers probably want more hours. Maybe they don't want to be part-time. And so they're more dissatisfied or neutral. When we look at the full-time, we can see they're mostly here around 4. So they're mostly satisfied with the hours that they're working. To show this on a graph, we're going to create a graph that looks like this, okay? In this first scenario here, we built this crosstab built on with the coded data. You can also do it here, and this one is with the, here if we have coded data, we need to add some labels to make this work. So if we are going from the coded data, then we're going to add this extra column here that identifies that question 2.1 is the part-time and question 2 is the full-time. So we're adding this column here, column called workload, and that simply allows us to then have the labels show up when we build this table here. So if you are not using if you're using data that's already been coded, you'll need to add in this label here. Okay. All right. So we'll say GP equals part-time and full-time. And then we're going to add that as a column or workload column and then output that new table. So you can see all we've done is we've added this extra workload here. All right, so now to create the plot itself, we're going to use dot plot, and we're going to plot from our bar 13. And we are going to then specify that we are going to plot. So here we're going to plot workload. That's the name of the column. And the kind equals bar H is a horizontal bar. And because we want to do our ordinal data, we want to do a stacked bar. And so stacked equals true. And you can set a color scheme. This is like we were talking about in the previous video. When you are doing ordinal data, we want, as you get more and more extreme one direction, it's more darker one color. And as you get more extreme another color, it's darker another color to show this transition here from completely dissatisfied to completely satisfied. So that's what we have here. We're going to label our x-axis as cumulative percentage. We are going to plot a legend. That's this piece at the bottom. We don't want this too messy here with a bunch of labels attached. So what we're going to do is we're going to put the labels in the legend, and we're going to have completely dissatisfied labeled on one end, completely satisfied on the other end, and 2, 3, 4 in between. Where do we want to locate this? We want to put this information, and this is what it's telling you here with the B box to anchor, is that it's going to be in the center, and you see the negative for the second, that's going to be below. The number of columns equals 5, and that allows for all this information to be side by side. So this here is some of the formatting that you can just leave once you've built one, or you have this example code here, and then you just trade in your own data. So we run this, and we've created our stacked here. So what this shows us, as we said, the part-timers are more dissatisfied with the number of hours they're getting, whereas the full-time are more satisfied. So we can do a comparison here where we have ordinal as one variable and nominal as the other. Before we leave this topic here, I just want to point out one other thing to you. If instead of using the coded data set, we had used the original data set, so data frame, DF, the Likert scale ones were still coded as 1, 2, 3, 4, 5. The difference is question 2 was listed as full-time, part-time. If you do it that way, so we're doing it from this data set where we have the question 2 is still in text form. If you did this and then you went to run this code, okay, if you typed in workload here, it wouldn't know what to do because you haven't created this new column workload. We just have the index here. And if you run it, it won't actually go. It doesn't like that. So even if you have this coded here like this, the easiest way to deal with this is to still create that new column called workload. And just notice here that the order is not matching as we do this. Instead of the 1, 2, it is putting it in alphabetical order. So it's putting full-time, part-time, which means we need to change so that the labels match. So notice full-time and part-time don't match because it changed the order of our information. So now they match full-time and part-time. And so then we can go back and still use our workload and then run that. And so again, you can see part-time more dissatisfied, full-time more satisfied. So if you are going to use data where it's not coded for one of those nominal variables, you will still need to add a column with the labels in order to create this rather than using the index itself.